Hey, what is going on, guys? Today we're going to do a little bit of a different video here. Today we're going to cover, at least with this playlist, we're going to cover algorithms and data structures. These videos in this playlist will not include any code. I will break those out into the languages playlist. So, for example, once we cover this one, then I can break it out to a Java video, I can break it out to a C, I can break it out to Python. So we'll do it that way. That way our videos aren't crazy long with trying to do it with 20 different languages or whatever I plan on doing with it. So we're just going to stick with data structures and algorithms. I'll go over them, and then in a separate video or videos we'll cover the languages. So this video will be fairly short. It is not a difficult algorithm. We will be going over the linear search algorithm. Super simple, probably the easiest one we will ever encounter. Linear search, and that's exactly how it sounds. So to start off, say we're so first let me explain to you, searching is good for basically going through any object such as a database, text file, and looking for a specific item or index. It doesn't have to be ordered, it can be unordered or ordered. But today we're going to cover an unordered data structure. So going for this, let's start with an array of A. And we can have a bunch of, we'll use integers here, that way it makes it a little bit easier. So we'll go 1, 10, 22, 5, 3. So there we go, we got a small array, not too complicated, not too large, fairly short. Now what the linear search is it's exactly how it sounds. Say we have a target here of a 5. So we want to return, what we want to return is the index of whatever, wherever 5 sits. That should be an equal sign. That's all hideous. So wherever that sits. As you might think to yourself, well, can't we just iterate through each index of the array until we hit 5? And you are 100% correct, because that's all that linear search does. Start here at 1, check if it matches, and if it doesn't check, then we move over to the next one. Doesn't match, move over. Nope. Oh, we got a winner, so we return 4 here, because remember, or 3, because index started 0, so 0, 1, 2, 3. So then now that question mark, erase properly here, will become 3, because index 3 is equal to 5. And to do that in code, it's just a super simple for loop here. We can, just say I is equal to 0. I is less than a dot len. Say I plus plus. Then if I equal to a. Oh wait, nope, that is not right. Target is equal to a I, then turn AI, or you can return I, because that would be the index. That's all that's to it. I know my handwriting's a little sloppy, so hopefully you guys can understand that. But that's all that linear search does. This is pretty. It is an okay algorithm. It's not the best to use. If you have a small array like this or a small, text file or database, a linear search is just fine because it does run at a runtime of worst case of n, which n is equal to a dot length, whatever the size of the array is. That's the worst case. So you have an array of 20 million items. You might not want to use linear search, as that can take quite a long time, especially if it's unordered. So you want to look for something that's log n. So we'll cover that in a different video as we go over different data structures. But that is all that is to linear search. As I make the videos for the languages, I'll post them down in the description. That way you can link to them or add them to the end of the playlist or end of the video here. But that is all for this video. Super quick, short algorithm. And hope to see you guys next time. See ya.